Good afternoon, everybody. First question of the afternoon, at least for me, right? Are you enjoying the conference? Learning a lot? Right, it's cool, right? That's good to know. Like, Strange Loop has been always kind of my dream to speak up, so I'm realizing this dream for the first time. So thank you for being here, like, making this dream come true. Right, so for those of you that don't know me, my name is Ricardo Ferreira. I'm a developer advocate at AWS, right? But I have a little bit of a story with the Apache Kafka technology. I kind of started using like in 2012, and then I started working for Oracle, doing some engineering, and then I built some plugins, adapters, transport for Kafka there, and then my desire to learn more about Kafka only increased, but not necessarily I accomplished that goal there. And then eventually I moved to being a developer advocate for Confluent. So some of you might have seen some presentations of me like talking about Kafka in the past. And then when I joined AWS, the first question that I made then was, all right, I can work for you, but can I still be working with Kafka? And they said, yeah, you can. All right, so let's keep going. So as you may know, I love Kafka, so that's why I'm talking about this. And one interesting aspect that I've been kind of noticing in the Apache Kafka technology is that it is a pretty battle-proving technology, right? You can all agree with this, and it has been around for a very long time, so you can definitely trust your production systems on this technology. But there's one element of Kafka that always bugged me since the day one that I started working with it, and it still bugs me, which is how many partitions you set for a Kafka topic, right? Anyone know like if there's some way for scientifically proven to set this? At least I don't, right? So the whole point of this presentation, actually there are two great points of this presentation. Number one, I'm going to show you what I have learned across all these years and how to best set a number of partitions to a Kafka topic, right? There's a little bit of a formula, right? But formula per formula, it doesn't help much if you don't know how to set the variables of that formula, which is the tricky part. And I'm going to show you how to do this, all right? So by the end of this presentation, hopefully, right, if I'm finished on time at least, you're going to leave this presentation with a concrete way to set the Kafka partitions. But I'm going to give you a heads up. It's doable, it's executable, but not necessarily easy. All right? I'm not promising you that's going to be, oh, no, I'm going to provide you a magic formula here that you're going to put on an Excel spreadsheet, and then you're going to come up with another. Honestly, I think we're all like developers here, and nobody would like believe in things. Someone would come to me and say that there's a magic formula for someone, right? We know that in software engineering, not everything is perfect. So that's the first topic. The second topic is that I am going to reinforce something that I've learned the hard way, which is everything in Kafka boils down to partitions, right? Or Ricardo, you're not exaggerating by saying that? Nope, I am not. Everything that you do, the way Kafka behaves, the way your expectation needs to be set in terms of what to accomplish with Kafka has to do with partitions. It is the primarily fundamental building block that you have to learn if you wanted to become an expert in Kafka, right? Because everything boils down to this. And you're going to see that I'm going to break down the Kafka the presentation into three different sessions, right? But how many of you have heard about this or even agree with this statement? Can you raise your hands? Like, do you agree that everything in Kafka partitions are only relevant when you start dealing with high-load scenarios? And I've heard this a lot. Like, for example, when I was a developer advocate for Confluent, where my bread and butter was Kafka, I used to meet a lot of banks and companies and communities and talk about their struggles with the technology. And then every single one of them, they kind of shared with me, Ricardo, I've never paid attention to partitions, but since we have to go to production next week and we are expecting some high load, what do you think about triplify the number of partitions to that topic? And I would always give the same answer. Don't do it. Don't do it. Think it through. Go back to the formula if needed, but don't do this. Don't change the partitions just because you're desperate, right? Partitions are not just like your magic formula for this. So yeah, the TLDR is that no, partitions are not only relevant when you're dealing with high load. Partitions are relevant since the day one when you start developing your code to your applications, whether they are simply integration scenarios with Kafka Connect or stream processing applications with Kafka Streams, KSQLDB, Apache Flink, or whatever other stream processing framework you're using, right? So In my opinion, right, and this is a kind of a Ricardo's definition of everything that I've learned so far. You can obviously disagree in the end, but in my opinion, partitions are a unit of storage of Kafka. It's the unit of parallelism. How do you achieve parallelism? And pay attention that I'm not saying unit of concurrency. I'm saying parallelism intentionally, right? I'm going to explain what the difference later. And also is the unit of durability, right? When everything else fails, if the whole Kafka cluster fails, it is going to be your way to recover from failures, right? But let's break down in presentation in 3 parts, right? So let's start with partitions as a storage, right? So number 1 fallacy that everybody falls into when they start learning with Kafka. I write data and I read data to and from a topic. That's not true. You write data into a partition and you read data from a partition, right? No, Ricardo, I'm pretty sure that when I write the code using the producer and consumer API, I mention a topic. Yes, because this is a high-level abstraction that the API and the API developers, when they were creating, they made you think that you were dealing with this high-level construct, but in the end, we are dealing with partitions, right? And honestly, and again, this is Ricardo's opinion right now, I think that was the most important mistake that the Kafka designers did in the beginning. They should have been straightforward in the beginning, because all developers that I talk to, they struggle with partitions. When you start talking about topics, everything is beautiful. But when you start digging into partitions, oh, no, wait, no, this is already too complicated. It's supposed to be simple. Let's move to Kafka to other messaging technology, right? This is what happens, right? But the good news is that once you understand, once you accept this in your heart, that everything is in Kafka's partitions, it becomes easier. And I'm going to try to accomplish this in here. Moving further, everything in Kafka, because again, we're talking about storage, right? Everything in Kafka is about partitions, and partitions are broken down into segments, right? So this is a snapshot of what is a partition on disk, right? And you can see that there's these 2 files over there, index and log, right? This combination of files represents 1 segment. Ricardo, what is a segment? A partition is a continuous log being appended to, right? But in order to ensure efficiency for the operating system, this log has to be broken down into multiple files, right? It's not good to have a huge file on disk. It's better to have smaller files on disk. By default, each file has 1 gigabyte of size, right? So a partition starts with 1 gigabyte. If you write 1 new byte after this, what's going to happen with that file? It's going to be not deprecated, but it's going to be put aside. A new one's going to be created, and the new event's going to be written to this file. So your partitions are broken down into segments. Clear? Okay, simple, right? Okay, and for each one of those files, the index file and the log file, by the way, the actual data is data or data? How do you call that? Data? Data? I don't know. Anyway, I derail. The actual data is written into the log file. The index is more for you to, is how Kafka kind of manages the offsets and the positions for that particular file, right? So for each one of those 2 files, it creates a file handle. So for those of you that have worked with infrastructure before, you know that every time you deal with a technology that creates a need to create file handles, that's a heads up, because that's the source of bottleneck. You can only create as many file handles in a given process per operation system, right? So here's a quiz for you. Imagine that you have a broker, a process of a Kafka broker that is able to create 1024 file handles, and then you have 1 partition, right? So if you have 1 partition, how many file handles you have already out of the box? I'm saying with my hands, literally. It's stupid to ask this question, so anyway. So imagine that you have like a producer that writes data every hour, and every time it writes data, it writes about 250 megabytes, right? So what's going to happen is that in 64 hours, that broker, which is kind of less than 3 days, is going to be running out of file handles, right? Because you have a theoretical limit of 1 gigabyte per segment, right? And I'm pretty sure that you know what you're thinking right now. Why the kid's hands are so dirty? That's the question that I've done myself when I took up this picture, but he's cute, right? That's what matters. So we're talking about like very deep disk infrastructure level, but let's come back to the real world here of developers, right? Actually, technically, the real world is the infrastructure, but anyway. I want to be like gracious with developers. Developers, when they are dealing with their APIs, they think about partitions anyway. But the problem is that everything is so well encapsulated using the APIs that they kind of are forced to not think it through. A producer, for example, when they send an event, there is this process that happens. And by the way, this is the new updated process of partitioning that was introduced in one of the latest releases of Kafka, right? And it is important for you to understand this because I am pretty sure that if you go to any public forum, community, or any person in the world and you ask, how do you do partitioning into Kafka? They're going to answer, oh, no, it's simple. You're just using, if you're not using keys, it's going to load balance across all the partition. If you use keys, then you're going to stick an event into a specific partition. Right, Ricardo? Not necessarily these days. It used to be like that. And more or less in Kafka 0.8, 0.9, give or take. But the specification has been improved a lot. And these days, this is the logic that applies. For example, by default, if the event has a partition set explicitly, then it's simple. It's going to use the partition. Go to that partition. Oh, there's no partition set, so that falls back to the partitioner class. It's an implementation that you can do in Java, Scala, or any other programming language, if that's support for this, that you can encapsulate the logic of the partitioning. Oh, no, there's no class that I've specified anyway, so then it's going to fall back to, there's a key. If there's a key, so it's going to apply the Merber2 function and on that key, and then divide by the number of partitions, and then find out kind of a round robin, if you will, of the key. Oh, no, there's no keys, there's no class, and there's no partition set. So then ultimately falls back to a logic that the broker implements to say, OK, this broker here is too loaded. So I'm going to send this event here for this broker here that's not too loaded. So, but you can see how complex is the algorithm that happens internally. And at a high level, again, you are simply, the produce sends data to broker, to a topic, right? But there's a whole partitioning plumbing that happens behind the scenes. The only problem is that you are not seeing it, or you don't want to see it most of the time, right? When you talk about consumers, the same way, like the consumer doesn't write, the consumer polls, right? Kafka is a poll-oriented technology. The broker doesn't push events to the consumers downstream. It's the consumers that pull the data from the brokers, just like you would do in a database, for example. So the logic that is applied for the consumer is like this. Imagine that you have like 3 consumers and you have fixed partitions. So by default, Kafka is going to kind of distribute all the partitions between the consumers. Oh, but if there are more consumers than, if there are more partitions than consumers, so the first consumer is going to receive an extra partition each until it distributes evenly for those. It works well, but it has one problem. And let's discuss the problem with a question. Imagine that you have a topic with 6 partitions, 3 consumers, and the range assigner, which is the default, by the way. Like if you've never heard about the range assigner, if you don't change anything in your consumer configuration, that's what the distribution is going to look like using the range assigner implementation, right? So the question is, one of the consumer dies. What's going to happen, right? So what's going to happen, believe it or not, is that the remaining 2 consumers will literally stop their processing of events. You know those hiccups that sometimes you see, oh, why the other consumers are not processing events just because this consumer here died, right? Because of the range assigner, right? That's the default implementation. And then this is what we call the stop the word pauses, right? So in order for the whole rebalancing, that's what we call in Kafka, to kind of, it needs to finish until the remaining consumers to remain and reset the processing for the events. Terrible, right? Not very good. Right? We have to come up with smart ways to do that. And that's why in the newer release of Kafka, they've introduced the cooperative stick assigner. How the cooperative stick assigner does, they basically, if they detect that one of consumer kind of dies, only the partitions that had been assigned to that consumer is going to finish the processing. Not finish, stop the processing, right? But the other consumers, they are going to continue their business as they should, right? And then what's going to happen later is that there will be an offline partition management for this. The consumer dies, and then the partitions are redistributed to the consumers that were already in the consumer group. So what is the lesson here? No stop the word pauses, all right? So why this is important? Because it is good for you to, remember that I said the range assigner is the default. Now that you know this, go to your Kafka consumers, switch to this. That's where we explain, for example, oh, I have Kafka here deployed on my Kubernetes clusters, and I see that my Kubernetes clusters, some of the pods are dying, and I don't understand why they're dying, and they're not processing events for this, because of this shit. Literally. It's a simple implementation that you can simply switch, right? So, again, everything in Kafka boils down to partitions and understanding partitions, right? From the storage perspective, well, Kafka uses a storage strategy that was very interesting in the past, and I'm going to explain why it's not interesting anymore, which is kind of a mimics how Hadoop cluster used to work, right? So it's a divide and conquer type of storage strategy. So if you have, like, for example, 2 brokers, each one of them capable of handling 1 terabyte per each, so you have a theoretical limit of 2 terabytes and a cluster size. Like, as you increase more brokers, you increase your storage capacity, right? Interesting, right? That's how Hadoop used to work for long days and works fine so far. The problem is with partitions, right? The number of partitions. Have you heard about that Kafka you cannot create 1 million partitions in Kafka? Because of this. Because of the whole strategy works. I'm going to explain in a bit about this. But let's do another scenario for you to make sure you understand, because again, we're talking about storage, right? Partitions as a storage mechanism. So imagine that you have a cluster with 2 brokers, right? And then you create 1 topic with 4 partitions. How those partitions are going to be distributed in the cluster? Evenly. That's the answer, right? So now you have 2 brokers, 4 partitions, 2 partitions for this broker, 2 partitions for that broker. Very simple. Right? Just like kind of the algorithm of the range assigner that we've seen before. All right, another question for you. Same scenario. Single cluster, 2 brokers, you create a topic with 4 partitions, and then that's it. And then you would end up with what we have here, right? 2 partitions per broker. But then you add 2 more brokers. Now you don't have 2 brokers, you have 4 brokers. What's going to happen? There will be no distribution automatic. Wow. So what's going to happen is that the 2 partitions are going to continue to live in the original brokers that were up and running, and those 2 brokers will be literally just sitting there doing nothing. And that explains, for example, situations like, Ricardo, come on. You said that Kafka is awesome. It is, by the way. But I doubled the capacity of my Kafka broker, and then instead of being faster, it's been getting slower. How can this be possible? Because of this shit. Right? Now, you might have worked, just a parenthesis, okay? You might have worked with some distributions of Kafka that does this kind of a redistribution automatically. The Confluence distribution, for example, which is one of the best ones in the market, they do this, but that's a proprietary extension. That's an enterprise extension. If you download Kafka from kafka.apache.org, it doesn't have this behavior, right? So you have to be aware of this, okay? Make sure you are aware of this. And by the way, this is true even if you work with Kafka on premises or Kafka in the cloud, right? It doesn't matter. Oh, Ricardo, I'm using the managed server from Confluent Cloud. I'm using Amazon MSK from AWS. I'm using the managed Kafka cluster from Avon. It doesn't matter. Same concept, because it's the default Kafka behavior. Okay? So keep that in mind. Now, how do you solve that problem? You are the operations team, or you're part of the operations team that has this problem in hand. You have 2 Kafka brokers that are just sitting there doing nothing. How do you solve it? Option number 1, bounce the cluster. Stop all the brokers, Q -9, all the brokers, and then when they come back, they're going to redistribute. Yeah, Ricardo, that's great, but it leads to unavailability, downtime. I don't want that. Can we do that differently? Yeah, you can use this kind of a Kafka partition reassigns command, and then you can redistribute it kind of automatically. Manually, right? With the cluster online. You want to see this, how it works? All right, so let me show you how this repartitioning works. So, what you're looking here is, I have a Docker Compose file that, as you can see, have a zookeeper, right? And you have the broker 1 that I've intentionally put the ID 1 here, and that is Kafka Confluence distribution, the community distribution specifically, which is to make sure that we're going to have the same behavior from the kafka.apache.org implementation. And then I have the second broker here, okay? And you're going to see that I have a 3rd and a 4th broker here, but they're coming out. So as I execute this Docker Compose file, which is DC stands for Docker Compose, okay? I'm lazy, so I kind of gave up on typing Docker Compose for all everything. I created an alias for this. So by the time it finishes, I will have 2 brokers up and running, right? So what I'm gonna do after these 2 brokers are up and running, are they up and running? Let's see. Healthy, starting, not yet. Healthy, healthy, healthy. Okay, everybody's healthy. So what I'm going to do is I'm going to use the Kafka topics command, right? That's going to point to one of the brokers, and they're going to create a topic called test, 4 partitions, and 1 replication factor, right? We're going to talk about replication factor in the end. So, right, here is the topic created. Good. And then I'm going to write some data in. Just make sure that it doesn't have nothing hello world. Of course, you have to start with hello world, right? What's up? Hey there. Strange. Loop. Rocks. All right, that's it. Now that you have a topic with data, we're going to do this. Kafka topics, minus bootstrap server. I'm going to describe. I'm going to use this command, describe. And here's the interesting part. You see, where's the, OK. You see where it says leader 1, 2, 1, 2? The 1 and 2 are the IDs of the broker. Broker 1, broker 2. So what is it reading here? The 2 partitions belongs in the 2 brokers, which is expected, right? You have 2 brokers. The partitions were spread evenly across the brokers, right? Now, what I'm going to do in my Docker Compose is uncomment the other brokers, the broker 4th and the 3rd and 4th brokers. Command /forward, and then I'm going to DC up minus D. All right, so the 2 brokers were already running. I'm going to spin up the new broker. So let's see when they start getting online. Starting, not yet. Starting, not yet. Healthy, healthy, healthy. So we have 4 brokers now, right? Now, if we rerun the command to describe the topic, which is this one, yay! The 4 partitions belong to the same 2 brokers in the beginning, right? So, which is the problem that I was highlighted before. So how do we change this, Ricardo? So any Kafka distribution has this command called Kafka reassign partitions. I'm going to type the command here. And before I run, let me explain the parameters. You see where I put it, broker list? That's your intention. You want to say, I want to generate me a recommendation that distributes the partition across all these brokers use, the 1, 2, 3, and 4, all right? There's some masks that you can apply if you have like a 24,000 brokers running, and you don't have to specify one by name, right? So you can definitely do this. But since I can count by name here, we can just run this. And you see that I'm providing a partitions.json file, which is this file over here. I pre-created before. It's a simple JSON file that you have to create it, by the way, that you have to specify what is the topic, and if you want to mention then by name, what is the partition of it. So you have to specify which topic, because you can have multiple topics, right? So when you run this command, it's going to say, how is the current assignment? Is this one. How is the proposed assignment? Is this one. So you're going to copy the proposal, and you are going to save that into a file that I've called it suggestion.json, but it can be anything. It can be Command V. Let's format the document so you can see better. All right, so this is the suggestion generated by Kafka, right? Kafka said that, right? So you can trust. Now that you have a recommendation, you can kind of rerun the reassign partitions command, but look that now I am taking as an input file the suggestion, and I'm using the command --execute, right? So if I run this, it's going to move the partitions, right? Keep in mind that, of course, this was fast because I basically wrote like 4 entries in the broker. But if you have like a large Kafka cluster, this may take a while to complete, okay? So this is a very sensitive command that you have to run when you are sure that your network is at least stable, okay? Otherwise, you're going to end up with corrupted data. Now that we have moved the partition, let's describe again the cluster. Let's see how it works. And great. Now the 4 partitions are evenly distributed across all the brokers. So now you can actually leverage your storage capacity of your Kafka brokers, right? So that's a way for you to kind of manage the horizontal scaling problem when it comes to storage, right? Oh, by the way, by the end of the presentation, I'm going to provide you not only the slides of this, but a blog post that I've wrote that has all the steps written down there. So you don't have to remember from the top of your head, especially on a Saturday afternoon that I'm pretty sure that everybody will remember. Forget about this after this, right? Now, we spoke about partitions as a unit of storage. Now let's talk about partitions as a unit of parallelism, right? So when it comes to concurrency and parallelism, what I always like to kind of explain to everybody that's come to me and say, Ricardo, can you give me tips about how to increase the throughput of my Kafka cluster? I always remember everybody that Kafka is an extremely, and most of the time, not always, but most of the time, a network and disk I/O bound type of architecture, right? What I mean by this is that forget about any preoccupation or worry about how many CPUs I'm going to set. Can I increase some? Can I use more optional performance CPU? Intel, like no Intel type CPUs? Forget about CPU. If you're not doing SSL offloading on Kafka, you're going to see that the Kafka utilization for CPU is very low. It has to. If your Kafka broker is using too much CPU, something's wrong here. Okay? It's disk and network, disk and network, disk and network. Disk for storage, network because producers write data and consumers pull data, right? So your first instinct when you are thinking about throughput is that, all right, remove the brokers from the equations, right? The problem usually is on the ends. Because remember, Kafka is a dump pipe, and it's by intention, it's by design, right? Kafka doesn't process anything. Remember, even the consumers, the brokers don't push the events to the consumers. The consumers go there and pull the data from Kafka, right? So what I mean by this is that another misconception that I've heard a lot of developers say is that, no, consumers and Kafka are pretty simple. You just have to continuously kind of pull all the events from the Kafka topic, and that's it. That's what I have to worry about as a developer. Bam, not true, right? This is the flow of what happens for every single event that you pull out of Kafka, right? Step number 1, the event pull itself. You will transfer the bytes from the broker to your consumer. It's a network traveling type of thing, right? Which, by the way, is already increases your latency because this is I/O. Then, okay, now that's the CPU part. You have to deserialize. Ricardo, what is deserialize? Kafka store in an opaque format. Everything is bits and bytes for Kafka, right? It's a log, remember? Then you have to deserialize for the actual protocol buffer, Avro, JSON, XML, CSV, whatever format you are dealing with. And this is a very CPU-intensive process, right? That's the problem of the consumer, but still is the CPU-intensive problem. Then you might have, not all the time, but you might have business logic, right? Which is something that you have to consider when you are processing the data. And lastly, you're going to commit the offsets, which is kind of the mark that, all right, this event can be marked as process. Therefore, in the next pool, the next event pool, it won't come up after. What happens if you pull the same event twice? You're going to process them twice. And if your processing requires writing them off into a database, that may lead into a data inconsistency, right? So that's why it's so important to commit the offsets. And so point number 1, processing the events takes some time. It's not just processing continuously. Problem number 2, that most of the time, I would say that that represent 80% of the throughput problem that I'm seeing out there. You are dealing with poison pills. Poison pills are those events that they're malformed, they're maybe missing a column, their data is kind of not finished yet, and then your consumers start processing them, and then it fails because they're incomplete, and then it goes back because if it fails, you cannot simply commit the offset, right? So you keep in this forever loop processing poison pills, right? So how do you do this? You can move these poison pills to another topic, another partitions, continue the processing for the ones that are okay, and then you kind of manually process the poison pills, okay? That's how you do this, AKA using some sort of a DLQ pattern, that letter Q, okay? Okay, so quiz time. You have one topic, 100 messages that we're waiting for processing, but 5 of them are poison pills. What's going to happen? Right, so what's going to happen is that no one knows actually what's going to happen. Because here's the thing, and here's the part that is kind of not very good when you were in the infrastructure side of things and when you were a developer. Because when you were infrastructure, you were flying blind. You don't know what the code is doing. You don't know if, for example, if the developer put a try-catch in the code, and it kind of caught the error or the exception and didn't propagate to the upper layers. If they did that, man, what's going to happen? There will be no exception to handle, and then the event will be marked as processed. But it wasn't processed. So you might lead to an inconsistency problem, right? So that's the pull, right? When you when you consumer code, you pull and then you process the records. Any exceptions that occurs from here, you have to make sure the exceptions are propagated to the handler, the upstream layers. Otherwise, this is why you need to do this, because this will signify that the offset commitment needs to stop, okay? That's good for consistency reasons. Another point that you have to worry about when you are troubleshooting throughput problems, pay attention on the network saturation, right? I've seen some interesting scenarios where, Ricardo, I would like to process 1 gigabyte per second of message here in my consumers, and I have this huge machine here, I have the best infrastructure, I'm running a bunch of BC2 instances on AWS, and for some reason, I'm not able to process like more than 100 megabits per second at a time. You know what? Because the network interface can only process 100 megabits per second at a time. So there's a network saturation, right? It's not a huge scalable like interface that's going to be elastic for you, unless you are using an elastic interface that allows that. But most of the time, they are set in stone, right? So pay attention to network saturation as well. Now, let's say you have like 10,000 events per second, that's your current throughput, and you want to double that. You want to be able to process 20,000 events per second, right? So what you do, you put another consumer in a consumer group. So theoretically, if one consumer is able to process 10,000 events per second, 2 is going to be able to process 20,000 events per second, right? Is this going to work? Have you noticed that I put the consumer room that's 0 load? Can anyone say why is that? Because you have one partition. And you can put 10 consumers, 10,000 consumers, they're not going to load balance in themselves to actually pull all the message from the partition. Only one of them will be working. It's a bummer of Kafka. It's by design, right? What you have to do, what you could do, is perhaps put them in different consumer groups. If you put them on different consumer groups, you know what's going to happen? It's going to work. But what Kafka is going to do is going to broadcast the same events, not new events or different events, but the same events to the 2 consumer groups. That's how you do pub/sub in Kafka, right? It doesn't work if you put them in different consumer groups. So the solution actually is you put them in the same consumer group, but create many partitions, right? And that's how, go back to the beginning, that's why I said that partitions are the unit of parallelism in Kafka, okay? So here's the point. How can I set the number of partitions in Kafka, right? Which is the question that I made in the beginning. So historically, there has been a lot of kind of attempts to create some kind of a magic formulas. This is a reference for that movie, Good Will Hunting, remember, from Matt Damon and Robin Williams, right? So when he was kind of a whiteboarding in the school, the college board. But you don't have to use like fancy. The point is that I always kind of try to explain to everybody is that stop with this desire to come up with the magic formula that you won't have to struggle to come up with to make it work, right? Life sucks. Life is not easy. Your developer job should not be that easy. Otherwise, anyone could do it, right? So what you can do is use this simple formula over here. The formula itself is pretty simple. How many partitions? You're going to use the max function. T is how many throughput you want. 20,000 events per second, 5,000 events per second, 1,000 events per second. W is the write throughput. How much write you can do, and how much read you can do. Come up with T, W, and R, you're good to go. Simple, right? Except that, all right, how can I come up with, the T is easy. The T is what I want. The T is what you want. I want 20,000 events per second. But where's the write throughput and read throughput? And this is the bummer that very few people know. Kafka provides you a tool for this. You know this. Kafka gives you the tool. It's a /bin folder of the Kafka distribution is right there, right? And I'm going to show you how to do this right now. All right, before that. All right. We have the 4 brokers up and running, right? I didn't. OK, they are up and running. So what I'm going to do now is create another topic. OK? Kafka topics, Bootstrap server. Topic is going to be called load test. And very important, when you do this sizing exercise, always create one partition, because it is your unit of measure. OK? In other words, you have to be able to say one partition can handle this. Therefore, 2 partitions can handle that. 3 partitions can handle that. You have to start with 1. OK? So create one partition, whatever topic you want to create it. And then here is the command. Before running, let me explain the parameters. So as you can see here, I have provided this producer.config. I have a config.properties file that's pretty simple. It's not fancy at all. It doesn't say that what Bootstrap servers I'm going to touch in the Kafka cluster, right? And then here's the interesting part. What is the throughput? The throughput is what you want, is your T, right? I want to be able to process 40,000 events per second. I want to. This is my dream. How many records or events you're going to send to Kafka? I'm going to send in 1 million events. Okay? Each event is going to have what payload size? 1024 bytes. This is bytes, right? And lastly, what is the topic, right? So I'm going to run it. And while the command executes, and as you can see this is on this /bin folder of your Kafka distribution. This is not something I created, or this is not something that any vendor created. Kafka.apache.org, if you download it, it's going to be there. So as you can see here, it doesn't send the 1 million events in at once. It's going to send in batches. And for each batch, it's going to tell you, first batch, I was able to send 11,000 records per second. Second batch, I was able to send 19 events per 1,000 events per second. Third batch, 20, right? And it also gives you the average of the megabytes per second as well. By the end, it's going to calculate an average for you, so you don't have to calculate this yourself. So can someone help me out? Take a note of 20,500, right? Remember this, 20,500. This is our write throughput, OK? All right. You took note? 20,500? All right. Because I will forget. I'm pretty sure that I will forget. So that's why I'm asking this. And then I am going to also, let's look how measure the read throughput. There was the write throughput, right? By the way, have you seen it that we've specified 4,000 events per second, but we were only able to process 20,000 per second, give or take? Because there's a bottleneck somewhere. It might be the network. It might be the amount of horsepower of CPU I have in my computer. I don't know, right? Some bottleneck is there. So you can either solve that bottleneck, or you can settle with that number. So keep that in mind. So now I'm going to do the same, but for read throughput. So this is simpler. You just need to provide how many up messages I want to process, right? So it's going to try to process or pull all the 1 million events that has been stored into that topic, right? So it's going to give you one row, one result row when it finishes. And we are interested in that column over here. Rebalance. Where's the column? No, it didn't show the column yet. All right. So because the font size is too big, but I'm not going to change the font size, but I will give you the number. This is our read throughput. 37,400-ish. You can load up for 37,000 events per second, right? So 20 write, 37 read. Can someone do me a favor? Maybe open a spreadsheet. It can be Google, Excel, and apply on that formula while I continue the presentation, because we are almost running out of time. But the formula is this. If you don't recall, let me show it again. So the function max, is someone's doing, or am I talking to myself? All right, the function max, and then the target throughput, again, is 40,000 events per second, right? Divided by write throughput, which is 20,500, and then comma, target throughput again, 40,000, divided by read throughput, which is 37,000. 2 partitions? Okay, good, thank you. So for handling 40,000 events per second, you need 2 partitions, right? So as I said in the beginning, the formula itself is not very complicated. But it is a hard work to come up with W and R. Just like the previous presenter in his session that he said by the end. It was funny because he basically summarized everything that I want to know in my presentation as well. You have to go through the process of proving a concept, right? That's the magic. That's the key. It sucks. You're going to struggle. It's not very fun to do that, but it's the only way. It's the only proven way, right? Okay, so we're running out of time, so let me just wrap up. The last part is going to be a little, and just 2 heads ups, right? That read throughput that we just did to measure, it only takes into account the event poll, okay? It doesn't take into account any artificial deserialization or business logic or offset commit. So you have to put this into your equation as well. You can put a buffer of 30, 40, 50% on top of it, whatever. Or better yet, measure this and try to distribute across each event. Okay, last part, unit of durability. So as you may know, Kafka has this concept of replicas built in, right? So when all the examples so far, we've created the topic with multiple partitions, but only 1 replica, replication factor of 1. This is an example of what happens if you set a replication factor to 3. So each partition will have the replicas distributed across all the rest of the brokers, right? Okay, Ricardo, I know that, but why this is important? Because if you set too much replication factor for each of those topics, or partitions, if you will, you're going to overload your Kafka brokers. That's one of the biggest, #1 C's that I've seen. People I don't know who was that, but someone in the internet come up with this kind of the replication factor should be equal to the number of brokers you have in your cluster. Why? Probably, right? But the problem of this is that imagine that you have a cluster with 16 brokers. You're going to set a replication factor to 16? Why? Why is that? Do you need that much of it's not even a high availability, it's fault tolerance levels in your brokers, right? And let me explain why this is important, right? I'm gonna skip to the end and then I'm gonna go back because the part that actually relevant is here. You know how replication works in Kafka, right? It's that simple. A replica does the job of keep pulling messages from the leader of the partition to stay in sync with that partition. We call them ISRs, in sync replicas, if they manage to keep in sync, right? That's the theory anyway. But what nobody realizes is that what the replica does is the same job of the consumer, a typical Kafka consumer that you would have in your application. They keep pulling. They are ultimately Kafka consumers. There's no magic. In order for you to replicate a partition, you have to keep periodically pulling the events from one partition to another, right? And this is network saturation, right? But more importantly, the network saturation, so take that in mind when you see all right, I want to process 10,000 events per second, and each event has 1 megabyte. So network saturation comes into play. And more importantly, you have to add that also replication will saturate the network. So point number 1. Point number 2, and I have to wrap up here real quick, but each broker, right? Imagine a broker. When a consumer sends a pull request to that broker, this is what happens behind the scenes. You have 2 pool of threads, it's Java pool of threads, right? It's called the network threads and the IO thread. So the request comes in, the network thread pool kind of put into a first in, first out in-memory buffer, right? That the IO thread's going to process them as they come. Therefore, they are FIFO, right? When the I/O threads finish processing those requests, it's going to reply back to the requester. This is the flow if you send a pull request to a broker. However, just like I told you before, that's the same flow that's going to happen for replications. In other words, if you have a broker doing too much replication, what's going to happen with your CPU? And that's what explains the so-called high CPU utilization on brokers. Too much replication factor, right? So the only thing you have to remember is replication factor is the same of processing events as if you are consumers, all right? Your brokers are going to suffer. Your brokers are the consumers, right? So just to wrap up, there are a few sessions of this presentation that I didn't. Oh, and by the way, those are the defaults of the polls. The network thread is 5, the output thread. What happens if you try to increase them? Because that will be kind of the network instinct, right? We're running out of threads. What can you do? Increase the pool of threads. No, don't do this. Because you're going to increase the context switching on the CPU, and it's going to make the problem even worse, right? So again, there's a couple sessions that I didn't spoke about because we're running out of time. But this is a good problem because I've wrote a blog post about this. Those sessions that I skipped, right? They're there. They're very well explained. I probably did a way better job writing that blog post than I did today, giving you this presentation. So just take your time, read. Everything is there, right? And most importantly, thank you. Thank you for being you.